Alright, for the next problem, we're going to divide two complex numbers. And again, the overall goal is to express this as an a plus bi. Now I've written a handy formula that tells us if we multiply a complex number by its conjugate, then the result is a real number. We will use this to clear the denominator. But the upshot is that we only have to know the coefficients here in order to find out what the multiplication is. So looking at this division problem, I want to clear the complex numbers out of the denominator. So I multiply by the complex conjugate of the denominator. The complex conjugate is the same number but with a subtraction in between. So 1 minus 4i. And what I do to the bottom I must do to the top. And we're off and running. So, up top we have 2 times 1. Then we have 2 times negative 4i, so negative 8i. Then negative 3i times 1 is negative 3i. And then negative 3i times negative 4i is positive 12i squared. All of this, and I'm not going to have to repeat that process for the denominator because I know when I multiply a number times its conjugate, it's this squared plus 4 squared. So I'm then set. The top has a 2 and 12i squared. I squared being negative 1, negative 12. Negative 12 and 2 is negative 10. Negative 8 and negative 3 is negative 11i. All over 1 plus 16, so 17. Now, like I said, we have to write this in terms of a plus bi. This is not a plus bi, so I need to break up my fraction. So I have negative 10 over 17 plus, actually not plus, excuse me, minus 11 over 17i. So there's your a, there's your b, there's your I.